Hello everyone and welcome to another data recovery session. Today I want to talk about table structure recovery. How to recover a table structure is one of the most popular questions I get, which makes sense because to read the record from InnoDB page, you need to know expected fields and their types. In the previous video about Undrop For InnoDB, I talked about cparser, a tool that fetches records from InnoDB indexes. cparser needs two things: a file with InnoDB pages and the table structure. So let's talk about the table structure. In this video, I will explain how to recover the table structure in different situations, what tools can do that, and of course I will show how to use each of them. There are two possible cases when it comes to the structure recovery. Case number one is when the table's FRM file is available. It can be so when you need to recover a corrupted table space. Case number two is when the FRM file is not available. This happens, for example, when you need to recover a drop table. As you remember, MySQL deletes the FRM file when you drop the respective table. For the case of the available FRM file, I will show two tools, dbsake and mysqlfrm. Both of them are essentially FRM file readers and produce the same result, create table statement. For the demo I will use two containers. One of them is a general purpose Linux container and one of them is container that runs MySQL server. In both containers I will mount a MySQL data directory that contains some IBD files and FRM files. And in this video I will recover table structure from the FRM files. So now let's start with dbsake. First of all, we need to prepare the container. I will update repo metadata, and while it's running, let's find dbsake. The installation is very simple. What we need is to download the tool, and it looks like it's a self-contained tool that we can run right away. Okay, but first I believe we need to install curl. Okay, curl is there. So far so good. +6 dbsake. dbsake requires Python 2.6 or Python 3. Okay, let's install Python. It's Ubuntu Focal, but it still provides Python 2 by default. Oh my god, 2021. Okay, well, it works with 2.7 Python, which is good. Kudos dbsake. So now let's restore table structure. I believe we need dbsake frm dump command, and it accepts a file as argument. As you remember, I mounted data dir, so we should have some FRM files here, and actor FRM. Super easy. So from actor FRM file we got create table structure. I don't know, very easy. Okay, now let's see how to restore table structure with MySQL FRM. Okay, first we need to run a container with MySQL. I know that mysqlfrm internally, it depends on MySQL server. It actually runs mysqld to read the frm file, so we will need it. Now I will use some of the official Docker images, in this case MySQL with 5.7. I will mount MySQL data dir to this container. And now let's connect to that container. MySQL and bash -l. Okay, good. What we need? We need to update repo again. And while it's running, let's Google mysqlfrm. mysqlfrm is actually a part of MySQL utilities from Oracle. Okay. Available from mysql.com. I played with it before. It looks like MySQL utilities do not get enough love from Oracle lately. It says it's archived version, and I played before recording this video with Debian packages, but unfortunately I couldn't find combination of OS version and MySQL utilities version to make it work. So I will just go ahead and install MySQL utilities from the source code. Alright, it comes as a zip archive, so let's install necessary packages in our container. Unzip and wget. Alright. We downloaded MySQL utilities. Let's unarchive it, uncompress it. Let's see what's inside. Inside we have a setup tools compatible Python application. So we can install it with pip. Let's see if we have Python at all. We don't. All right, let's install Python. And by the way, MySQL utilities need Python 2. Unfortunately, it's still Python 2, but okay, what can you do? Okay, and the tool that we need is mysqlfrm. Okay, good. So we now have the tool. Now let's try to run it. It's not as easy as dbsake, and this tool needs a little bit of black magic to run it, but let me show how to do that. So first of all, it will need a path where it can run, where it can find mysqld, MySQL actually installation, and by default it's /user on Linux machines. Then mysqlfrm will actually run mysqld. So we will need to allow mysqld to run as user. So that's why we need --root. And what else we need? I have mysqld running in this container on port 3306. So I need to pick some other port. So that's all of the black magic, and now we need to pass a FRM file. And hopefully it will work. Actor FRM. no such option root. Maybe I made a typo, maybe it's allow root, I don't remember. It's okay, / user root. Okay, good. So it's starting MySQL D right now. The MySQL D will read the FRM file and it will produce create table statement, as you can see now. How I would compare these two tools? I like very much dbsake. I like it very much for its simplicity, very easy to install, very easy to use it, and looks like produces valid result. MySQLfrm, on the other hand, is a little bit trickier to use. Fortunately, I do have experience with MySQLfrm, so it was relatively easy for me to figure out how to start it. If you're just a beginner, it's probably gonna take some time, which is very valuable when it comes to data recovery. So for table structure recovery, I would recommend to check out dbsake first, but if it doesn't work for whatever reason, the second quite viable option is MySQLfrm. It's not a big deal to recover table structure if you have the FRM file. Everybody can do that. But in real life scenarios, when you drop the table, you don't have the FRM file, you don't have the IBD file. What can you do then? And before jumping into data recovery Kung Fu solutions, I would encourage you to think out of box and maybe try to find table structure from other sources. But with one precaution. It is very important for data recovery to get 100% accurate table structure, because even one bit matters. If the column is the wrong size, cparser, for example, it will shift 1 byte, and of course it wouldn't be able to read correct values. Even null, not null attribute of a field matters, because null, not null uses a bit. It can shift data one byte, and again, instead of valid records, you will get junk. So the table structure must be accurate. Now, what other sources of the table structure can it be? First of all, if it's some third-party service, maybe the table structure is available in installation scripts. An obvious example would be a WordPress website. The WordPress tables are well known. They come together with WordPress installation, so maybe you can get it from there. The same applies to WordPress plugins. They all the table structure for tables of those plugins are available from the installer script, so check them out. If it's your application developed in-house, maybe you can find the table structure in version control system, in some, I don't know, migration scripts, in some repo, I don't know. But think about if there is an alternative source for table structure. And the reason for that is because even though it is possible to recover table structure from internals of InnoDB, often it's not reliable process, and always it's difficult to do it. Nonetheless, if you ended up with no other options and you do need to recover table structure from InnoDB dictionary, let me show you how to do it. So here I have the same container with MySQL service. I have my MySQL 5.7 here. I have some tables here, but let's pretend that we do not have FRM files and we need to recover table structure from InnoDB dictionary. For that, we will need TwinDB's tool, Undrop For InnoDB. Undrop For InnoDB. Undrop For InnoDB. Still typos. Okay. Let's clone it here. Do we have Git? We don't. Let's install it. Git. Git clone Undrop For InnoDB. Undrop For InnoDB itself has several dependencies that I'm going to install right now. Those are make, JCC, flex, and bison. Now, if you compile the tool with the make command, it will compile stream parser and C parser. Here we have C parser, here we have stream parser. We will need stream parser later, but it doesn't compile sys parser. Sys parser is the tool that reads InnoDB dictionary from tables uploaded into a live MySQL instance and produces create table statement from this InnoDB dictionary. To compile sysparser, we need a libmysql dependency. I don't remember how it's called exactly, besides on different platforms it's different. So usually what I do is I search for something like MySQL and dev. Okay, it looks like the package that I need is libmysql dev. Let's install it. Okay, now let's try to compile the tool, and it works. Good. Now we need the dictionary. Sysparser assumes that you already recovered the dictionary, and the dictionary is uploaded into some live healthy MySQL instance. I do have live healthy MySQL instance on this container, but I don't have InnoDB dictionary in it. So how we can do that? So first of all, we can use stream parser to parse ibdata1 file. Let's do that, because our MySQL ibdata1, because InnoDB dictionary is stored in ibdata1, and to be more precise, it's stored in these 5 indexes from 1 to 5. These are 5 different tables, and InnoDB dictionary is stored in those files, in those tables. Now we need to take these page files and generate table dumps and upload them into live MySQL instance. I have a helper script here, recover dictionary, that does exactly that. It reads InnoDB pages, it recovers dictionary tables from these pages, and it uploads them into the local MySQL instance. But there is one detail that you need to take into account. You have to understand what happens when you drop a table. When you drop a table in MySQL, and let's say it's InnoDB table, and let's say InnoDB file per table is on, what happens is MySQL deletes FRM file, MySQL deletes IBD file, and also InnoDB deletes a record in its internal dictionary about the table that you dropped. Okay, so that means if we need to recover InnoDB dictionary with deleted records, because you need to recover the drop table, then you need also to recover deleted records from InnoDB dictionary. That's why cparser accepts -d capital option. It will recover records that are flagged as deleted. In this example is different a little bit. We didn't drop a table. The table is live, it's available, so InnoDB dictionary doesn't have a deleted record about this table. So for that reason, I will not recover deleted records. I will recover only live records from the dictionary. I hope it's not confusing. So let's do that. Now what happens is recover dictionary reads records from these 5 files, and it recovers only 4 tables out of them. These tables together they contain different pieces of information that you can use to reconstruct table structure. This is basically what cparser does. All right, now back to cparser. It accepts database name and table name in this format, database/table. So if we want to recover Sakila actor, that would be the comment. But cparser, unfortunately, it cannot read myCNF that I have on this container. So I have a myCNF with username and password. So I have to specify that explicitly. This tool. Okay, if everything goes right, you will get output with create table statement. Now it's important to know that this output is slightly different from output that you get with dbsake or mysqlfrm. And there are 2 reasons for that. First reason is dbsake reads a FRM file, and the FRM file is the source of truth for the table structure. InnoDB, however, it copies data from FRM file and stores it internally for its own internal purpose, and not all information InnoDB needs that is available in a FRM file. For example, InnoDB doesn't care about comments. So that's why not all information is available in InnoDB dictionary, and that's why sysparser cannot recover like 100% matching structure that you would get from FRM file. The second reason is table structure that sysparser recovers is necessary minimum that is needed to successfully read records from InnoDB page. And that's why, even though it's possible, sysparser doesn't recover secondary indexes, for example. Table actor does have a secondary index on the last name, but sysparser doesn't recover it. This is something to take into account if you recover the table and you use table structure from sysparser. Keep in mind that you will need to recover secondary indexes as well. Alright, that's probably it. So as you can see now, there are multiple ways to get the table structure back. To summarize, if you have the FRM file, try out dbsake first. If you don't have the FRM file, try to find the structure elsewhere, and if you cannot, use sysparser from Undrop For InnoDB. Of course, it's good to have options, but even better is to prevent any need for data recovery. Be sure to check out my TwinDB backup tool. It is open source, and most importantly, you don't have to write shell scripts to use it, which makes it truly the backup solution. I'll leave the GitHub link in the description. Good luck and take care!